Alright, number 10, we got 5 parts. Ronald Fisher is considering the father of experimental design. Ronald Fisher is considered the father of experimental design. Being of English descent, he was having afternoon tea with a colleague. The colleague's wife entered the room as Fisher was pouring tea. Being the gentleman that he is, he offered her a cup of tea. She politely accepted and requested milk with her tea. Fisher started to pour milk into the teacup, but first the lady indicated that she prefers tea to be poured first, then the milk. Fisher did not believe that the lady could tell the difference between milk first versus milk second. The lady insisted that she could tell the difference. Being the consummate scientist, Fisher suggested an experiment in which he randomly poured milk into the tea first, in some instances, and milk into the tea second. It turns out the lady tasting tea was correct in all 8 trials. Complete parts A to E. So if we assume the lady was simply guessing on whether the milk was first or not, what is the probability that she would guess correctly in any given cup? Okay, so this problem we have 2 options. Milk first or milk second. Okay, so since there's only 2 options and if we're just doing a random guess, they each have a 50% chance. So she got a 50-50 guess of being right. That would be anybody that didn't know. Okay, so the chance that she would just guess any cup would be 0.5, 50%. Okay, so assuming guessing correct on one cup is independent of guessing correct on another cup, what's the probability of guessing 10 consecutive cups? So since we have, I'm going to say probability C of being correct, okay, is 0.5. So the chance you would do this 10 times in a row, meaning they're independent, would be probability that she gets all 10, so it'll be to the 10th power. So that's going to be 0.5 to the 10th power. So what the calculator is doing is raising this to scientific notation. So this is saying this is 9 point, I'm just going to do 4 decimal places, 7.656, and then that E means times 10 to the -4, so like scientific notation. So that means we're going to move the decimal place 4 times to the left. 1, 2, 3, 4. So that means 1, 2, I would have to add 3 zeros. So what this number actually is 0.0009, and then we got digits. So we are wanting to round to 4 decimal places. So this 7 would round up, so that would give me 0.0010. 0.001. C wants me to explain how a coin could be used to simulate the random process. So a coin also has 2 sides, 50% chance. So the likelihood of obtaining a head with a fair coin is 50%. So, which is the same likelihood of guessing. So we're going to use the coin flipping applet in StatCrunch to simulate the experiment 2,000 times based on the simulation. What's the probability of guessing on 10 consecutive teacups? So we're going to open StatCrunch. We're going to do simulation coin flipping. StatCrunch. Tablets. Simulation. Coin flipping. Okay. We're going to just input all these. So we're going to set number of coins to 10. And we're going to use fixed seed as 1128. So number of coins 10. Use fixed seed 1128. Alright, so what else do we need to do? We're going to click compute and then click 1,000 runs twice to simulate 2,000 runs. Do not click the reset button. Okay, so we're going to compute 1,000 runs and then 1,000 runs. So we got 2,000 runs. Okay, so based on this, the probability of guessing correct on 10 consecutive teacups. This says, looks like 0. If you look at the height of these bars, these would represent the percentages or the number of times we got correct in those. And when we get to 10, there's no height. So according to this, there's a 0 chance that she would guess all 10 right. Part E. What do the probabilities from part B and D suggest about the lady? Choose correct. So B and D. B says that if she guessed all 10, she got a .001, which is really, really small. And D said that there's no way she could guess all 10 right. And in the experiment, she did. So that says the probability of the lady guessing the correct order of milk in 10 trials is very low. Evidence suggests she was not guessing. That looks good. Probability of the lady guessing the correct order in 10 trials. Evidence suggests she was guessing. Nope. Probability is very low. Evidence she was guessing. Probability of the lady guessing correct in 10 trials. The evidence suggests she was not guessing. It's high. No, it's not high. So A is going to be the best answer choice. It's not high, it's low. All right, and that'll wrap us up.